Good morning, good afternoon, ladies and gentlemen. A warm welcome out of Germany and even out of Wallingford, Connecticut from me and my colleagues. So thanks for joining again to our web seminar. And the third and last session. And today we will give you information on the surface protection by wax additives, and even Eddie Carruthers will give you some information how to fight against the foam in your systems. So I will start today giving you the background information on our wax additives and how you can beneficially use them in your systems. As I told you already on the first day, so before I became the end-use manager for the home care and industrial solution market, I was working for 12 years as a product group manager for wax additives, and I almost have about 15 years experience with wax additives. So I'm really glad giving you the insights about our products here. So starting with how to protect the additives, how to protect your surface, sorry. First of all, I like to clarify what is a wax. So you know from the surface presentation on Tuesday, you can describe it by chemical structures. That's impossible with waxes. So waxes are hydrocarbon chains, linear or branched, but nothing special where you can make modifications on. So therefore, wax is a technological collective term, and if a raw material fulfill the coming properties, then it will be called a wax. So for example, the melting point of at least 40 degrees C or 100 F, so in opposite to fat and oil, which has a much lower melting point. So first of all, this is a performance to achieve. The next one is low melt viscosity. So that's important too, but you know for sure if you melt butter in a pan, even butter will form droplets immediately, has a low melt viscosity, but of course you have to add the high melting point to it, so that's what it is. So it should be both to become a wax. And last but not least, no chemical decomposition. The waxes are inert, you don't have any chain which can break and could be modified, so that's the reason why waxes give a pretty permanent protection, because the durability is pretty high and the product stays stable in comparison to a natural resin. So if a material fulfills these three properties, then it will be called a wax. And the classification for waxes, so the origin are the natural waxes.
Anna?
Yeah.
Shannon here. Sorry to interrupt, but we don't see your presentation.
Oh, sorry. That's, of course. And by the way, I can't even see you anymore. Where are... Can you see it now, Shannon?
Yes, it's not in presentation mode, but I see it. There we go.
Yeah?
Yes, I see the natural waxes, the living.
Okay, so just sorry for that. Okay, so again, I think it's no need to tell you again what is a wax, but at least I want to show you the slide is so, and of course these are the classification. So yeah, again, sorry. And yeah, going further, so the origin of the natural waxes are, natural waxes are defined in living nature and fossil waxes. So on one hand, we have the animal waxes, so pretty well known as beeswax here. And on the other hand, we have the plant waxes, the canola wax. So greetings to Brazil. So that's where the canola wax is original from. So just in the rainforest in Brazil, you will find the canola palm tree where the palm tree has to produce the wax to protect the leaf due to the weather circumstances in the rainforest. You can't find it on any other place in the world. And a product which becomes more and more attractive nowadays due to the interest in more natural sources as well, the sunflower wax, which you find in India and China pretty often. And this is now an industrial grade. You may have heard about such a product from the cosmetic industry in the past, but now it's available even in industrial grades. If we talk fossil waxes, so we have the wax from crude oil, that is paraffin wax, out of the decomposition of petroleum. And next to it, the montan wax, which is mainly coming out of the eastern part of Germany and even out of Ukraine or America. So these are almost all natural waxes we are using, and just want to draw your attention on the black color of the montan wax. So that is the reason that these products will be modified and will be called then a semi-synthetic wax. The montan ester wax will be bleached, and so the color change and even the bad smell as well, so then it can be used as a wax additive. And next to it, the amide waxes are called semi-synthetic either, so they are based on fatty acid chemistry, and the one with the highest melting point is the ethylene bisteramide, the so-called EBS wax, and these are the one which is used for additives as well. Talking about the synthetic waxes, these are of course the ones which are mainly used in the industry, and that's polyethylene wax, low density and high density polyethylene, which will be oxidized just to change the polarity, that it's easier to emulsify the products. We have the Fischer-Tropsch waxes, called by the reaction of Mr. Fischer and Mr. Tropsch, and the polypropylene waxes. And next to it, the copolymer waxes, the ethylene vinyl acetate products and ethylene acrylic acid, EVA and EAA waxes. You may have heard about these wax bases because they are used pretty often even in floor polish for the anti-slip properties. So these are the different waxes which are available. So these are the raw materials. So BYK is not producing any raw wax. So we just make, we make the additives out of it. And the reason for it is, and you may know it as well if you have used the raw wax by yourself to make your own products in your production. So you will get this raw material as flake, granules, plates or powder, and it looks like this. And a paraffin block can be even this size or bigger, and it's pretty difficult to handle it in a production. So that is the reason for making additives out of it, to get it in a much better handled particle size distribution. And that's what you see here, though, if we talk about ready to use wax additives. So we have aqueous, solvent and solvent-based system. You see here the wax emulsion and the wax dispersion, and next to it even micronized waxes, which are a white powder, of course. But here you always have the chance to have wax additive, which are pretty easy to handle in production, easy to incorporate in your systems. The product technologies we offer in BYK are the entire technology range which is available for making wax additives. So on one hand, we produce water-based wax additives, so the wax, so-called wax emulsions. Of course, it's still pretty small particles in water, so it's a pretty fine dispersion, but it's been called emulsion since ever. And the products which we offer here are the AquaCer products, so Aqua Latin for wax and Cera Aqua Latin for water and Cera Latin for wax. We have the Aquatix product, which have a thixotropic behavior, and we have the Hodamer products, which are primary wax emulsions. We even do a wet grinding process to have bigger particle size distributions in our water-based wax additives, and these products called AquaMat, and due to the bigger particle size, they will give a matting effect. If we concentrate on solvent-based products, we have on one hand the precipitations, these products named CeraFuck and CeraTix, and on the other hand the wet grinding products, so similar than the wet grind in water-based system, but here of course we have to work with pretty low energy to keep the product stable. So that means such a wet grinding process takes about 3 days, 24 hours milling. And here we have products like the Ceracol, which are based on polar solvent. We have the CeraMat product, so even here the matting effect similar like the AquaMat types, and the mineral oil-based wax additives, which are mainly used for printing ink industries. And last but not least, the solvent-free products, the micronized products, which are named CeraFlower. So this product looks like a white flower. If you look to the particle size distribution of these different product groups, so the one you can use for high gloss systems are just the wax emulsions. They have a particle size below 1 micron and have no effect on the gloss. All other products will give you at least a turbidity in your system or even a pretty nice gloss reduction. And we have even some CeraFlower which has a pretty high particle size distribution above 100 microns. So here you can have a very nice smooth texturing effect, which gives you even a good soft feel. So what are the effect you can achieve in your system by using a wax with a bigger particle size distribution? It is on one hand the haptic, so the soft feel effect on a surface, the touch you just get if you can feel the bigger particles. If you have a particle of about 300 nanometer, that's pretty difficult to get a really good silky feeling on it. So therefore bigger particles have an advantage here. And of course next to it, it is the matting effect, which you will achieve by using an AquaMat type. If we look on the chemistry of the wax, so what are the surface effects you can achieve by the different wax bases I have shown you before. And in order to get scratch resistant, you of course have to work with harder waxes. By talking about hydrophobicity, non-polar waxes are pretty important to choose. Abrasion resistant, even here you have to have a look of the waxes which give you mechanical properties or polishability. So the surface slip will be related to the wax base either. And if you have a closer look to it, so based upon the melting point of the wax, you can achieve different performances. And that's the reason is if you have a close look to the data sheet of the wax additives you want to use, you will see for sure the melting point and due to the melting point, you can get the first ideas where you will, which performance you will get out of it. So if you're working with a wax that has a melting point below 100 degrees C or about 200 F, then you will increase the slip properties. And of course, increasing slip means even a good polishability in your system. If you use a wax base which has a melting point above 200 F, 100 C, you will increase the mechanical resistance of your system. And last but not least, if you use a wax with the highest melting point above 150 C or 300 F, then you can increase the anti-slip. Though, of course, by the lowest melting point, you have the highest slip, and the slip decrease by a higher melting point. And if you put the wax bases inside, which I have shown you before, so then you will easy to judge that all waxes which are below 200 F are the natural waxes. And these are the ones which give you the best slip properties. And for car polish, furniture, leather polish, these are the perfect products. If you think about floor polishes and you need mechanical resistance for foot traffic resistance, for example, then you can think about the Fischer-Tropsch or low density polyethylene waxes. They are on the borderline, 200 F, 100 C. So this is almost a good start with to have bit slip and some mechanical resistance, but the best products here are the high density polyethylene or the amide waxes. And if you think about anti-slip properties for floor polish, dancing floor, sport floor, or so on, then the polypropylene waxes are the right one to choose. And if we add our products, and we will focus today on the wax emulsions, because if we talk the polish market, it's mainly water-based, and so that's why I draw your attention on our wax emulsions today. And I think it's easy for you to judge now that these products, of course, are based on the natural waxes, paraffin, beeswax, sunflower wax, or canova wax, the 1031 low-density polyethylene, as I said, on the borderline. We have a product which is based on polyethylene containing PTFE. PTFE has no melting point, so that's the reason why you find the product here. And with the Aquacel 8075, you have the perfect wax for mechanical resistance on floor polish, foot traffic resistance, and the 8976, obvious, it's a polypropylene wax for the anti-slip properties in floor polish as well. To give you some ideas about the background on the wax chemistry, I think it's time for getting into the applications, and I will start with the floor polish products, and of course buffability, anti-slip, filling properties, and foot traffic resistance are the main performances you will look for if you think about wax additives. And the performances will come out of the wax you choose for your system, and as well due to the polymer you are using. If it's a metal containing or metal free product, the styrene acrylic emulsion will give you a certain effect, either next to the effect you can get by the wax additive. So water and alcohol resistance, low dirt affinity, the resistance to foot traffic is belong to the polymer performance, and the wax give you buffability, anti-slip, the filling properties, and the removability. And depends on the chemistry of your polymer, it will make sense to really have a look to the best balance of both products. As I told you before, we have two products tailored for the floor polish market. We introduced them about 4 years ago. These are the Aquacare 8075 and 8976. So the 8075 is based on high density polyethylene 275F, 135C in melting point. So these, of course, is a product for the best mechanical resistance, and the 8976 with 320F melting point, of course. This is the one which gives you the best anti-slip properties. And even here, the balance is important and depends on the polymer you are using. It might be a good idea to check different ratios here. Of course, the 8075 will increase the hardness and the 8976 the surface slip. And I'd like to show you the effect with this crocodile battle. So what you see here are two panels where we applied a floor polish. One is just with the 8075 and the one behind with 8976. And now you can see with the race who is the fastest crocodile, and that is the one has less anti-slip, and that is the 8075. So just as one test for the slip measurement, you have seen on Tuesday, we do as well some Altec measurement. So it's not just the crocodile we are using, but it's even here a nice measurement to see how the slip will behave in such a system. Oops. So, but as I say, so we can even measure the slip. And here we took the high density polyethylene wax as a reference and say that has a zero slip, and compare the 8976, the pure polypropylene next to it, and you see we can achieve a minus slip, which is minus 100 in comparison to the pure polyethylene wax. And with the ratio of 3:1, 2:1, or 1:1, you can really see how you can adjust the slip performances in a floor polish by the mixture of high density polyethylene and polypropylene wax. So we really recommend you to use a combination of both. Talking mechanical resistance measurement, here we are using our Sartre tester on one hand. So what we are doing here, we place a substrate in this device and the stamp is going down, and on the stamp you will see at the end the felt pad, which you see here. So that's here another stamp, I wouldn't name it. And then this felt pad will rotate on the surface, and so we will get some scratches. So after defined time, so normally we turn 10 times and then we measure the gloss. And what you see here, so this is a PMMR panel where we applied a floor polish, put it here under the felt pad after 10 rotations. So you can see here the scratches which occur due to the turns. And we measure the gloss before and after the rotation, and that gives us, and the gloss we measure gives us a certain idea about the mechanical resistance and the hardness of the floor polish. And that's what you will see here. So we have the gloss measurement without the Sartre test. It's 99 gloss units. By doing the test, so it's after the Sartre test with the high density polyethylene, we still remain with 99 gloss units. By using just the polypropylene wax, the gloss drops by 4 units. And if you compare the different mixtures of 3:1 and 2:1 polyethylene and polypropylene, the gloss remains the same like the high density polyethylene, and just by using a bigger amount on polypropylene, we see that the gloss is getting down again by about 4 units. So it's still okay, so it's not a big damage, but at least you can see here pretty well the differences. The next test we are doing here is a so-called crock meter test. So here we are using a sanding paper, which is which we scratch on the surface, even here about 10 times, and we will measure again the gloss before and after the scratching. So here you can see how it works. So even here we use the PMMA panel, apply the polish, and after 24 hours we do the test. And here you see the results. So even here the gloss is going down with the pure 8075, even more again with the 8976 due to the melting point. So it's not, the polypropylene wax becomes a bit brittle, and that is the reason why it's never as good as a polyethylene wax. And what you see here as well, that the mixture of both give you the best surface protection in a floor polish. So these are the standard products which we recommend in floor polishes, and I'm pretty sure that you are using polyethylene and polypropylene wax in the systems too. But I want to draw one attention to you as well, that we will have some issues in the future with the synthetic waxes. So as you may know, a hot topic in Europe is the ban of microplastic. And the ECHA, the European Chemical Agency, will ban microplastic, and the ECHA will most likely pass the law beginning of next year. And then we have a transition time in Europe for about 5 years to substitute the synthetic waxes, the microplastic in a polish, by a product which is either natural based or biodegradable. So I don't know if it is an issue for you as well. I know microplastic is an issue in almost global nowadays. I think each agency have different ideas here, but at least if you export to Europe, that will be something which might be of interest for you too. That's the reason why I want to show you 2 examples. So what BYK is developing now to come up with products which can substitute the high density and polypropylene wax in the future. So we have here a starting point formulation which contains our sunflower wax, Aquacer 570. And you might think about, from all what I told you before, it cannot work because the melting point is below 100 C and will never give a good mechanical resistance. If you see the gloss retention by the Sartre and crock meter test in comparison to the polyethylene wax, and here you see instead of 8075 the 1075 and the 1076. These are the European version out of the 8075 and 8976, because we test in European systems up to now. But the effect will be the same if we use the American versions out of it. So what you see here is that the gloss remains almost the same, even slightly better. So that looks pretty well. And the reason for it is, of course, slip increase. So what you see here with this blue bar is the slip in percentage. And so you see here that the slip increase with about 60%, so that might be for sure an issue on a floor polish. But if you look to the COF, the difference, what you see here, the column, so it looks, of course, less than the PE and PP waxes, but here we are pretty sure that with the adjustment of the right polymer, that we can make something out of it. So that is the first idea, to start with sunflower waxes here. We have to go for the natural waxes and find a way to eliminate the slip properties. So we are even working with rice wax, with sugarcane wax. So you can look forward, we will come up with some new products here. Next to it, I like to draw your attention to our wax-like polymers, which are bio-based. So here we are using biorenewable sources, which by fermentation get a microorganism. This one we can micronize, and what you get out of it is a biopolymer, which is 100% biodegradable. So we go two directions. We have on one hand a natural source, which is accepted by the ECHA, and on the other hand, 100% biodegradable. These are micronized products, so Sera flowers, so they might be of interest for you if you are looking for semi-gloss floor polishes. And here we have three products to offer: the Sera Flower 1000, 1001 and 1002. So they are different in particle size distribution, and they will give you an excellent matting. But of course, you have to take in mind these are 100% products, easy to incorporate, but you need a certain shear forces here. And on the other hand, you have to get it stabilized. So we talked about rheology yesterday. So here with about 0.5% Optigel CK, we were able to prevent settling. And what you could see here, so from a high gloss system, 93 gloss units by 60 degrees, we can get a really smooth matte surface on a floor polish with a gloss of 60. And if you adjust the level of the Sera flower, of course, you can achieve even a semi-gloss. So that might be as well of interest for prevent using PE or PP waxes and microplastic products, because even the silica will have some issues in the future. And now let's talk about car polish for a while. So here, of course, waxes are an important raw material as well. So you need them to get the polishability in a car polish. Water repellency, a big issue. Filling properties, again, surface protection and high gloss normally. And if you look which kind of products we need here is for polishability, again, low melt point waxes, or if you will use a machine polished product, then of course we can even go for high melting point waxes, which gives you a better surface protection. So here we will recommend a Kanawa wax, or for the hand polish, or the 1031, the low density polyethylene wax for machine polishing systems. Water repellency, here of course you need low polarity waxes, which give you a non-polar surface. Even here our Kanawa wax will give you a good performances. But here I like to draw your attention as well on the Aquacer 1550R, which is our PTFE modified wax emulsion. And you may have heard about the PFOA issue in the past. So since May this year, last year, to get the REACH compliant product, you have to have a PFOA content below 25 ppb, and that is what the Aquacer 1550R fulfill. So this is a product which you can use easily to get a good water repellency. Filling properties, the low density polyethylene wax will do a pretty good job. Surface protection, you can think about sunflower wax, the 570 as well, and again the PE PTFE product. And of course, if we talk about gloss polishability, all products which are mentioned here will do the job in your car polish. just showing you how we do the tests in our lab. So what you see here is a engine hood, and all our starting point formulations you will find on the web are developed by our lab staff in Wedel and in Wallingford. So you see here when we start the polishing, we started with a gloss unit of 1.4. So what you see here now is that we do machine polish on the hood to increase the gloss. And so that of course will occur in first of all cleaning the surface. So of course we have abrasives here in the product which will give a smooth surface, and even with the wax inside you can increase the gloss. And so in such a formulation you will find next to a wax the silicone emulsion which we talked about on Tuesday, the 9890, even Optigel WX for anti-settling of the abrasives. And last but not least, it occurs in a pretty nice gloss, which has a gloss unit of 71 after polishing. And if you take the same car hood and make a water repellency test, you see here that's how it looks untreated, though your contact angle of the water droplets is not pretty high, so you have a good substrate wetting here with the water, that what you of course wouldn't like. And what you see here by machine polish, what you have seen a minute ago on this movie, by using car polish based on carnauba wax and low density polyethylene wax. So we have pretty nice contact angle of our water droplet. And so if you would have a rapid drying with an airstream, so these water beads will be able to roll out on the surface pretty easily. And if you look to a hand polish product with Aquacert 565 followed by a car finisher containing the PTFE wax, what you can see here, though the water droplets are even smaller and pretty easy to get out of the from the car surface. Talking leather polish means here it's important to have as well, next to the standards performances we talked about, hydrophobicity of course, and oleophobicity. So that's important as well. If you talk leather, it's not just shoes. If you think about leather shears, so oleophobicity make sense, surface protection, high gloss. So that's important properties you might look for. So what we do for our testing for the hydrophobicity, so that is a standard test from the German Leather Institute. We use the so-called Lafer substrate, which is a standard substrate you can buy and have always the same kind of material. If we do this hydrophobicity test, we use always a water isopropanol mixture, starting with number 1 with 100% water, and then increase the amount of isopropanol. And you see, without wax, we don't have any protection, so the leather absorbs the water in a minute. And after 2 minutes, by using this test fluid number 9, so 20% water, 80% isopropanol, so pretty severe test, by using leather polish containing Aquacert 570, we still have a perfect hydrophobicity. Next to it, we do the so-called rain test. So here we pour 500 milliliter water on the substrate and will count the amount of tests we do until the leather start to absorb the water. And what you can see here, so we were able to pour it 5 times on the substrate before we saw any absorption by using the Aquacare 570, which, as you know from the beginning, it's based on the sunflower plant wax. Pretty often paraffin waxes are used here based on crude oil. Of course, it is a pretty good product for leather polishes and cheap as well in comparison to a sunflower wax. But if you think about the consumers nowadays, so they are driven by sustainability, so that has a big image into the market. So here, if you think about a new development for a more greenable product, it might be a good idea to have a closer look on our Aquacare 570. Carnauba wax is used here as well, but wouldn't give you such a good water repellency. Beeswax does a good job, similar to the paraffin wax. Montan wax can be used here as well, but even here the image is not as good if you think about the consumers. And high density polyethylene, that becomes microplastic, so even here we have some image issues. So that's the reason that we really highly recommend to consider if such a unique sunflower wax, microplastic-free, natural source, biodegradable, may make sense if you think about new developments for the consumer market. And I'm proud to tell you that we are the only one who offer a sunflower wax emulsions. So that means we have dedicated wax additives for dedicated performances, and you can achieve by using the right wax additive the performances you look for in your system. Doesn't matter if it's floor polish, leather, or car polish. And if you think about mechanical resistance floor polish, of course, our high density polyethylene waxes, polypropylene, or even our natural waxes could be the first choice for you. Thinking about hydrophobicity here, the natural waxes will be more non-polar and give you a good effect here. Talking abrasion resistance, even here the hard waxes will give you a perfect effect. And if you think about car polish, then of course we talk about Carnauba wax for hand polishing, the 1031 as a low density polyethylene wax for machine polish, and our brand new Aquacare 1550R PTFE, which gives you a perfect water repellency, even in combination with the BYK 9890. So that's the end of my presentation. So thanks for your attention and listening to it. And now I'm getting back, I hope.
Hey, thank you, Anna. Thank you for that presentation. I have one or two questions from the audience here. Can you talk about how you decide how much wax to use?
Oh, that's a good question. Yeah, what we normally say, you should cover the surface of your polish with the wax to have the best surface protection. So we normally recommend to start with about 2% solid wax on total formulation, and then you can adjust it, getting less or more, depends how the polymer which you are using gives the properties, but that's a good start.
Thank you. And then touching on the microplastics ban, which you mentioned, can you comment some more on our recommended replacements or future developments, how we're tackling that issue?
Very good question. Yeah, we have a project running, as I mentioned. So we are testing up to now all kind of natural waxes which are available, even the biopolymers. So as I mentioned, we have different kind of wax bases like sugarcane, rice bran wax, which will come, I think, next. So these are the products we are thinking about. So if anybody of our customer are interested in a cooperation, so please come back to us. So here for sure we can offer you some new lab products which shows pretty good effects.
Hey, thank you.
You're very welcome. And I think if we are done with the question, I think then we should now continue with the presentation on Fight the Foam, which will be held by Eddie Carruthers, our colleague out of Wallingford. So Eddie is with us since about 3 years, but he has 30 years experience in the HI&I industry. So he is doing all our application tests in our Wallingford lab. He even is visiting customers, supporting them by application tests. And if the circumstances are back to normal, so normally he's at least once a year in Germany and visit our lab. And like the discussions and training with the German colleagues, and even enjoy a good German beer in the evening. But now I think he will not talk to you about the beer foam, but for sure about foam and some HI&I systems. So please, Eddie, it's your turn.
Thank you, Anna, for such a wonderful introduction. Hello, everyone. And first, I'd like to personally thank everyone for taking time to join us here in this final session. In case you haven't heard, our subject matter today is on defoamers. And if you're in need of defoamers, you must have foam present. So today, we will fight the foam. Our topics today will include what is foam, how foam is stabilized, the mode and action of defoamers. We'll take a look at the defoamer classes and how to select the proper defoamer, and we'll finish up with the test methods for defoamers. In certain applications, foam is not only an issue, but it is wanted. And there are as many applications where foam is not only wanted, but it is enhanced, created, and stabilized for that particular application. However, in some applications, like current laundries, foam is not only unwanted, it can cause major issues. Generally speaking, foam is nothing more than a dispersion of a gas in a liquid. And it doesn't occur just by chance. There are certain circumstances must be present for foam. There has to be a source of the gas. There has to be surface additive or surfactants that reduce the surface tension. And then the formation of foam must be faster than the foam breaks down itself. There are several different types of foam. There's microfoam, which contains bubbles greater than 100 microns, and there's microfoam with smaller bubbles, generally between 10 to 70 microns. Then there's wet foam and dry foam is a result of wet foam when part of the water has drained from it and the foam has become hard and, as stated, dry. Dry foam is probably the most difficult of these to handle because once dried, it has to be re-wetted prior to breaking. And generally speaking, foam, all foam, any foam has a combination of microfoam and macrofoam, which are smaller bubbles and larger bubbles. The issue is that the more smaller bubbles you have, the longer the foam is lasting, because as we will learn later, the smaller bubbles create or grow into bigger bubbles before they dissipate. Now that we've seen the types, let's see where foam comes from, or the gas that creates the foam. First of all, in application, it can be from the substrate. In production, it could be from ingredients such as fillers and pigments that are added into the formulation. It could be in production and process by incorporating and mixing or grinding to create the product. And finally, it can be from a reaction that's going on in your formulation or solution. These are all gas creators that creates foam. Pure liquids do not foam. When bubbles are created in a pure liquid, the bubble rises to the surface, and once it reaches the surface, simply because of gravity, the water flows from the lamella, and as a result, the bubble breaks. However, once surfactants are added to the system, now at the air and liquid phase, the action occurs where it's stabilized by the surfactant molecules, and no drainage is possible. So the foam stabilizes and you have foam. And foam is stabilized by several mechanisms. The first mechanism we'll speak of today is known as formation of electrostatic and steric repulsing double layers. Then there's the Gibbs-Maragona effect, influence of viscosity, and the fourth is retardation of gas diffusion. The mechanism for electrostatic and steric repulsion is a result of either anionic or non-ionic surfactant molecules connecting at the air and liquid phase, and become stable and create foam. And this is both in electrostatic is a result of anionic surfactants. And here steric repulsion is a result of non-ionic, but they're both caused by just a surfactant molecule. And the Gibbs-Maragona effect, again, it's by surfactant molecules, but it is a result of a change in the surface tension. Adding surfactant to a solution, the surface tension is generally lowered. And basically, when you change the surface tension of a liquid, whether with anionic or non-ionic, what you're really doing is creating lubricity to it. So instead of a bubble breaking, a surfactant gives it the ability to bend in some cases, and in other cases, it'll stretch. But in both cases, the stretching and the bending allows the lamella to maintain shape as opposed to bursting. And our third mechanism is influence of viscosity. And I think we're all easily familiar with this process. We all know that the thicker a product is, the slower a bubble is removed from the product. So an increase in viscosity causes a delay in the foam rising or bubbles rising, and if they don't rise, they can't break. That's the scientific theory behind it, but basically, if the product is thick, bubbles rise slowly. And our final mechanism is even simpler. Small bubbles turn into large bubbles. So if you have a large number of small bubbles, it will take longer for you to get the foam removed, because in due time, the small bubbles before bursting will turn into large bubbles. So you're looking at a much longer time. Now, why is foam such an issue? There are a lot of consequences with foam. In production, it can require a longer field time, as well as an error in mix volumes. It also can cause technical performance in the product's application, poor application properties, such as here. And this is one that I am very familiar with. I have spent a great deal of time finding a proper defoamer in a floor finish system. And the interesting thing is, it rise to why there are so many defoamers. I have experience where here big 1679 works great in this application, or even better in this formulation. I have seen very similar formulations where it's still a floor finish, but instead of big 1679, I may have to go with 094 or one of the other products, simply because of a change in the polymer in that formulation. Foam prevention. In a perfect world, it is much better to prevent foam than having to fight it, because preventing foam will allow you to proceed without adding an additional item to it. Of course, we sell a lot of defoamers, so that's not always the case. But one way to prevent foam is to optimize the production process. Another is to pre-wet all the solid particles so you don't have to mix as long when you're producing. And minimizing foam stabilizing components. In other words, if there's a way you can take certain items out of your formulation to prevent foam, that's a good thing. And the final way is to adapt or optimize application processes and types. However, that is not an easy answer. Therefore, we have defoamers. Next, we'll look at the mode of action and how to get a good defoamer, or what's required. A good defoamer must first lower the surface tension of the solution, provide good spreading availability, and as strangely as this sounds, it must be incompatible in surrounding media. And that particular one is where the questions become difficult, because while it has to be incompatible, it still has to go in your system. And for that reason, we have defoamers of multiple types: mineral oils, polymers, and silicones, because trying to meet all three of these in so many different systems is impossible for one defoamer. There is definitely not a one size fit all in this scenario. And in being incompatible, there is an optimum spot that must be formed, because if the defoamer is too compatible, we will actually enhance or generate foam itself. If the product is too incompatible, it will be cloudy or cause defects and look very poor in the final product. So we have to reach that wonderful spot for defoaming and incompatibility, so we kill the foam and not make any negative impact on the appearance or the performance of the solution that we're trying to defoam. Here we see an example of spreading of defoamers. Here we have a layer of water in a petri dish, and we're adding just 1 drop of defoamer. Okay, let me slow this down so you can really see what's going on. I think that is considered rapid spreading. That's one thing you highly look for in a good defoamer. Another method is destabilization of the lamella. And basically the lamella is just the outer surface of the bubble. When foam is stabilized, this is the connectivity you see. Now looking inside this area, when you're de-wetting with a defoamer, the droplet goes in, starts the water to run out, and as the water runs out, the lamella shrinks and breaks. Foam destabilized. Another process is where we're actually using spreading as opposed to de-wetting. Again, foam stabilized. Defoaming occurs. The droplet spreads, burst. And yet another, there are hydrophobic particles involved, where hydrophobic particles are dispersed throughout the defoamer along with defoamer oils and sometimes polyurea waxes and other ingredients just to stabilize it and hold it in solution. And while we still get the effects of the oil, the added particles give it more stability, faster break time, and more permanent results. This is known as pin effect, which creates faster defoaming. Now, here at BYK, when we're formulating defoamers, there are several considerations. First, we have to decide on the active or the carrier, which can be mineral oil, or polysiloxane, polymers, or polyglycols, or a hybrid of any of those. We have to decide if we're going to make it a particle with hydrophobic or urea or polyamides and other ingredients such as, believe it or not, surface active agents, which is what we're developing to fight against, but it is required. And when formulated properly, we deliver formulations of defoamers that are 100%. Some are solutions, some are emulsions, and we even have a line of powder defoamers as well. And there are influencing factors when choosing a defoamer. First thing you have to consider is point of addition. Where in your process do you want to add your defoamer? Then once that's decided, how long do you want to incorporate the defoamer? The shorter, the better, because in most cases, incorporating any material into a liquid, air is created, which leads to the possibility of foam. And then we have to look into the shear force, because the more shear, the more possibility for air to be introduced and more foam. Then we have to consider the dosage level. In some cases, a high dose could cause more problems than the help that it will provide. And finally, we can select the proper defoamer. These are all the influencing factors that you have to consider when selecting a defoamer. Some of our other influencing factors are the formulation style with chemicals, possibilities, which production step, the application process, how it's going to be used, required efficiency, and defoamer base, whether silicone or silicone-free, and one that is often forgotten is compliance. Are you under any special restrictions for EU, FDA, or in the crazy world of California? And here's why there are so many defoamers. Because there are so many situations, applications, and solvents. Here's one defoamer in 3 different solvents. Same defoamer, 2 incompatible, turbid. Here we are. Unacceptable. So just by this demonstration, this demo alone, there are 3 defoamers there. And those were just pure liquids. And all the solutions and applications available requires all the different defoamers that we and many of our competitors provide to the industry. Overview, in defoamer declassification, there is mineral oil, silicone, and polymer. And mineral oil defoamers are usually selected mostly because of their cost. They are very cost effective. However, they are the least effective and least compatible with most situations. And then the silicone defoamers are very effective in many systems. They are VOC and emission free, but they can be sensitive to pH above 10. And then there's the specialty or polymer formulas, and they can be a combination of mineral oil. They are generally mineral oil and silicone free, and they can be a hybrid of silicones and siloxanes and many wetting agencies. They provide strong defoaming properties, low influence on surface tension, large pH acceptability, and can be VOC and emission free. And our defoamers come in a variety of appearances. Nice, clear solution. These are non-aqueous emulsions. Many of our 100% compounds have a turbidicency. And then we have aqueous emulsions, which look like a thick milk. Here is a selection of our popular silicone-free defoamers, mineral oil defoamers, and our silicone defoamer. Now, in our silicone-free defoamer, one specialty is our BIC 016, which is listed in the 40 CFR 18910 regarding EPAs and ERTs. And we also have product not listed here, that is our BYK 1740, which is completely formulated with renewable sustainable materials, completely biodegradable. So keep that in mind if you're looking for a high-end renewable product, and that is BIC 1740. And here is our agitation test that is used in both our, whereas several solutions to the left or without defoamer, and the 3 to the right are with defoamers. So they're just agitated. And we can measure initial and stabilized foam. And as you can see, 3 solutions, 3 different answers. And here is an actual testing center located in our Basel, Germany's facility, where we actually do testing with actual clothing and actual front load washing machines. And here on this selection chart, the use of silicone defoamers in aqueous systems. As you can see, the starting point formulation would be a recommendation for 1723, because what you're looking for is you want high defoaming properties, but you also need high compatibility. While 1679 has higher incompatibility, that it may not necessarily be very good in certain aqueous products, whereas 1723 is right in the middle and may be a more all-around product. But as I stated earlier, there is no all-around defoamer because the world is full of solutions and applications. And here are 3 of our silicone-free defoamers for aqueous solutions: BIC 11, 14, and 16. And again, these are all particle-free and silicone-free. That is the end of my presentation. I would like to thank you all for your time and look forward to any questions you all may have. Thank you again.
Thank you, Eddie. I think that was really great how you explained to kill the foam. There are 2 questions for you. I think we're still in good timing that we can do it. So do you have a product recommendation to start with while testing the defoamer?
Well, because we have so many defoamers and there are even more different systems and applications, I would refer anyone to our brochure or direct contact with us, because the choice of a defoamer is strongly dependent on the system. But for full polish, I would recommend a starting look at our BYK 1723.
Sounds good. And I really subscribe what you said, is that it's always good to get in contact with us, and we are for sure more than happy like Eddie, you will do it in Wallingford, or even our colleagues in the Sao Paulo lab, or even Wesel to help you out, because as Eddie mentioned, we have plenty of defoamer and each system is different, that's for sure. So Eddie, one other question for you. Which defoamer are stable at very low pH values?
Low pH. Well, most silicone defoamers decompose in low pH systems, and not only will they become ineffective, it could cause some other issues. So while some mineral oil defoamers may work, the best choice in a low pH system would be a polymer-based defoamer.
Okay, so thanks a lot. Then all other questions we got from the audience, we will answer by email later today. So thanks again for your presentation. And so, ladies and gentlemen, we are almost at the end of our web seminar. I like to summarize what happened, and I hope now it will work with my presentation better than before. So I hope you can see it now. And yeah, just to summarize what you have heard the last 3 days is that I'm pretty sure when we started on Tuesday, so at least I hope you were curious what information you would get in the seminar, and if it will be beneficial for your daily work. And we all really hope that after 3 sessions of our web seminar, that you will know and have some creative ideas in mind what you can do with all the information you have got from us, and yeah, and get some new ideas how to increase the performance of your formulations, or even develop some new performances out of these additives. What I would like to show you and draw your attention to is our website. So if you go on www.BYK.com, you can immediately find the HI&I market and the industrial and the button where you can get all information on the product itself. So if you click on the product, you find information, technical data sheets, safety data sheets, even information about REACH or food contact, and these kind of pretty important things. You will see as well if we are planning a web seminar. If you are looking for any personal contact, you will find as well here all information about our agents. You can get in contact with, or even ask us, we get you in contact with the right person. You can find our brochure, which you can download, and our starting point formulations. Just one word about our brochure. So what you see, if you see here the content of the brochure, so here we go even more in detail by application, cover all application we talked about during the 3 days. But here again, even solvent-borne cleaners you will find here, and additives for high solid cleaning products, so fabric softener. So you will find here a lot of information about the different application in HI&I. And one last thing, because it's nice still to have some paper, but what you can do as well to stay in touch with our additives is, so I highly recommend our to-go product. So if you download our big app out of the additive, the Apple Store or the Google Play, it will be as well all information like you get it from the website, and you have everything in your hands to find all the information you will need. And if you can't find what you need, or as Eddie mentioned, if you need more information, more detailed information for your system, then please send us an email. You will get an email, of course, with the certification. You can even request sample from us. So for sure, we stay in touch with you, and from all the colleagues, we really want to thank you that you have joined this web seminar and you stayed with us. And yeah, so last but not least, I have to say thanks a lot for joining. It was a big pleasure for us to have this web seminar with you, and we're all looking forward to stay in a personal contact face-to-face again, and I hope that will happen in not too long time from here. So I don't know, Shannon, do you want to say some words either before we...
Hey, sure, a lot of thanks. Just to reiterate, we appreciate everybody's time and participation this week, and there will be an email coming out with, as Anna said, links to the certificate. We'd ask that you complete a form so we spell your name right. There'll be some other stuff in there, including links to the presentations, so you can go back and watch those, and links to some of our supporting information that we talked about this week. So, but if you need anything, feel free to contact us here. Either the group email or our direct emails. We're here to help. Thanks.
Yeah, so yeah, we really have to say so. Goodbye, stay healthy, and auf Wiedersehen.
Cheers.
Tschüss.